Let me check with the Raidu whether they're going to join or not. And who is the other one? Okay. Let us complete the concepts of this map reduce today, and maybe tomorrow I'll start talking about the practicals, how exactly we need to do, and then we'll take it from there. Okay. 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 So Murli, you can see the screen, right? Divya and Shashank.
Yeah.
Okay.
Yes, Ravi.
Sure. Yeah. So the first thing is this is your client. 1 minute. This is your client. Okay. The client is having a certain objectives that he would like to fulfill. The client is having certain objectives that he need to fulfill. So the objectives are like this. Store a file of 1 TB in size. Store a file of 1 TB in size. Okay, and then find out the total occurrences of every word in the file. Find out the total occurrences of every word in the file. This is one thing that you would like to see. Okay, now so for that particular purpose, what we are having is see here. We are having a file. See here, we have this particular file. Okay, which is of 1 terabyte in size here. Which is of file.txt, which is of file.txt. Okay, and here this is 1 terabyte in size here. Okay, and also what you're having is that you have a program called as word count. Word count. We have this word count program, which is used to process this particular file in order to count the number of occurrences. Okay, this is what is required here. Now, see here. What are the things that we need to understand here? The first thing what we need to have is that we need to have the name node. This is what is generated as a name node. This is your name node here. This is what is your name node. And the name node is going to maintain an image. This is what is called as FS image. This is what is called as Shashank. You need to understand FS image is nothing but a file that maintains the metadata of the file what you are storing in the data nodes. Okay, this is what is your FS image, contains the metadata. Okay, this is what is your metadata here. Okay, and assume that you have these data nodes here. These are your data nodes. One, these are your data nodes. This is your second data node. This is your third data node, and assuming that this is your fourth data node, along with you have this particular fifth data node that exists. This is your fifth data node that exists here. Okay, and so this is your data node, and this is what is your FS images that are existing here. Okay, I hope this is clear to you. Now, what is going to happen here? This client is going to contact this name node. This client is going to contact this name node to ask for the storage where this file.txt has to be stored. Where this file.txt has to be stored. Okay. Now, what this particular file.txt is going to be done here? This file.txt is going to be split into two files. This file.txt is going to be split into two files. Okay. One is nothing but your file1.txt, file1.txt, and then file2.txt. And what is the default size of the block here? What is the default size of every block here? Okay, file1.txt and file.txt are generally treated as splits. They are nothing but they are treated as the input splits, right? They are generally treated as the input splits. They are generally treated as the input splits here. Okay. Now let us try to have some caveats that we are trying to talk about here. Let us try to understand these caveats here. What are those? Let us try to caveat here. The block what you are talking about here, the block size what you are talking about here is of 64 MB, 64 MB or 128 MB, 64 MB or 128 MB, and the replication factor what you are having here. Hi Sarvanan, how are you? Okay, 64 MB or 128 MB here. Okay, and the second thing what we need to do is that the replication factor is going to be 3. The replication factor is going to be 3 that you are having here. That means that number of blocks has to be stored. And here what is going to happen is that assuming that this is being specified as 1 here. This is 1. And this is specified as 2. Okay, this is specified as 3. And this is 4, as well as this is 5, and what you're having here is that you're having this 6 that exists here. 6. These are the 6 things that you're having here, which are treated as the data nodes here. Right. Okay. Now here I need to maintain the metadata. In what way I need to maintain the metadata? The metadata is like this. That is file1.txt. File1.txt is going to be stored in 3 files. That is 1, this is 3, as well as this is 5. Okay. Similarly, file2.txt, file2.txt is going to be stored in something like 2, and this is stored in 3, and this is 3, as well as this is stored in 6. So this is what is the metadata that I'm having here. Okay, so the client is going to contact the name node for the purpose of storing this file, and it is being split into file1.txt and then file2.txt, and these are nothing but the input splits what you are having here, and this is the place where this data has to be stored. File1.txt has to be stored in 135, as well as file2.txt is supposed to be stored in 2, 3, and 6 here. Okay. Now what you're having here is that here I'm having this one as 1 is stored here. Okay, and similarly here also 1 is stored here, 1 is stored here, and in 5 also 1 is stored here. In 5 also 1 is stored here. Okay, similarly 3, 5, 1, 3, and 5 it is stored here, and then this is the place where your file is stored. This is 2 that is stored here, as well as 3 that is stored. 3 is something where this is also stored here. This is a place where 3 is stored here. That is, sorry, 1 and 2 are stored in this 3 node, as well as you also have 6. This is the place where your 2 is also stored here. Okay, this information is being maintained like this. Okay, so as I have told you here, this is what is your FS image, and every data node for every 3 seconds is going to provide the heartbeat interval. Is going to provide the heartbeat interval for to the name node, specifying that the data node is alive. Okay, and then it's also specifies for every 10 seconds, for every 10th heartbeat, it is also going to send you the block file. It is also going to send you the block report. That block report says that how much storage is consumed, and within that every storage how many file splits are existing, how many file splits are existing. At the same time, it is also going to tell how much is the free space that is available. Okay, depending on the information, that block report is being sent by the name nodes. Block report is being sent by the data nodes. That name node is going to maintain that information within the edit logs. Name node is going to maintain that information within the edit logs, and accordingly, it is going to uh, understand the dynamics of this data nodes here. Okay, at any point of time, if the data node fails, obviously what happens here, the replication factor is going to be distributed across the other nodes in order to make sure that the balance of that replication is being maintained across with a factor of 3. Okay, so one more thing I want to tell you, Sarvaran and Murli, to your question, what we have discussed last week, maybe on Monday, I don't know. The thing is, the blocks are written to the data nodes sequentially only. The blocks are written to the data nodes sequentially only. Okay, that is for sure. And the logical questions what you're having here are ruled out. Blocks are being read, blocks are being stored sequentially, as well as blocks are also read sequentially only. So there is no case of parallelism that happens. There is no case of parallelism that happens, especially when we are trying to read the data, especially when you are trying to write the data. The way in which you are going to save the file, which you are going to save the processing time is, since each and every block is going to be of 128 MB or 64 MB, what happens is that the larger the size of the block, okay, the minimum time that is going to use to write the data in those particular blocks. Is it clear, Sarvanan, what I'm telling you?
Yes, definitely. That's what I also thought actually.
Okay.
The write portion will happen sequentially, block.
Okay.
I mean that read will also happen sequentially. Okay, great.
Read also will happen sequentially. But
Okay.
the parallelism, that is, see, parallelism is something that will not happen within the storage processing. Parallelism is something that will happen in processing the data. Parallelism is something that will happen in processing the data. That is the place where we are trying to, exploit the performance gains in terms of processing the data. That is how we are going to see here. Okay,
Right.
so Sarvanan, before you started joining, I just gave you an overview here. That is,
Yep.
the client is there. He wants to store a particular file, which is a file.txt, which is of 1 terabyte in size. Okay, and that file is going to contain some text, some information. It is going to contain some textual information is going to contain. So in order to keep the things simple for the clarity of the example, we have two input splits. One is file1.txt and second is file2.txt. Okay, that information is expected to be stored in these blocks. Okay, that information is expected to be stored in these particular blocks. So client contacts the name node for the purpose of storing this information. But the name node, what it does is, it based on the block information that is retrieving, as well as the heartbeats it is retrieving. Okay, what it is going to do is that it is going to allocate 1, 3, and 5 data nodes for these 1, 3, 5 data nodes for what? 1, 3, 5 data nodes for the file1.txt, and then 2, 3, and 6 for this file2.txt. This is something that is going to happen.
Okay.
Okay, now
Ravi, did you say reading is also block by block sequentially?
obviously. See, just want to make sure that whether all your components what you are talking about here are running successfully or not. What you need to do is that you need to get into the terminal and then you need to start giving this particular sudo command, which is nothing but an administrator based command, and then you need to specify JPS, and it is going to give you these particular nodes are running successfully. These particular nodes, what are the name nodes? You have this name node that is running, you have the data node that is running, you have the node manager along with the resource manager, you have the job history server along with the JPS. These are all the things that are running, so we are good. Okay, so what I want to do is that Murali and Sarvanan, I want you guys to provide me your email IDs. Okay, so that I can start sending you the instructions for the purpose of creating the local host, for the purpose of creating this local host and the Edureka virtual machine sandboxes or some other even Cloudera virtual machines also I'll send you, and you need to start installing these sandboxes so that maybe from tomorrow onwards you need to start doing these practicals also as well. Okay, this is one thing that you need to understand. And here you are also seeing something called as node manager along with the resource manager. So Sarvanan, have you heard about something called as YARN?
Yes, it's the Hadoop.
It is yet another resource negotiator.
Okay.
See, the version of Hadoop what we are using is 2. Okay, MapReduce is the concept that is there in Hadoop version 1. From Hadoop version 2 onwards, what has been done is that from Hadoop version 2, what has happened is what are the shortcomings? 1 minute, guys, please hold on. Subbu, good evening. Yeah. Hello. Hi, guys.
Right.
So I was talking about something called as the yet another resource navigator. Whatever the shortcomings what you are having with respect to MapReduce, in order to overcome those shortcomings from the release 2 onwards, what has been done is this is another concept that has come up at another resource navigator. So if you want to correctly understand what is that yarn, we need to really understand what is going with respect to this MapReduce and how exactly we can have the option of writing those Java-based Hadoop programs and then how to execute them. The moment once you have that particular clarity, then we can go ahead and then start looking into those yarn and other concepts here. Okay. So, Sarvana, is it okay with you? That's how we are going to proceed. Yeah.
Sure.
Okay. Now, so this is how the storage has happened. And one more thing I thought of asking you, Murali, I have a question. You have this name node as well as you have this data nodes, right? So are these name nodes and data nodes physical nodes or virtual nodes?
They are physical nodes.
Virtual
They
name
are
node
not
is
the physical nodes, guys. They are the virtual nodes. Okay. The reason is that this entire HDFS, what you are talking about, the Hadoop distributed file system, what you are talking about, it is an virtual file system, right, Sarvanan? It is a virtual file system. Okay. And the name node is nothing but a process that runs in its own separate Java virtual machine. Okay. And data nodes are also the processes that runs in a separate virtual machine. So whenever I talk something called as a data node, it does not mean it's an physical node that fails. It is not a physical node that shuts down. It is a virtual node that generally shuts down. It's a virtual node that generally shuts down. Okay, so that is one thing that you need to understand.
What I meant,
Okay.
Ravi, is that in a normal production, enterprise production implementation, you assign a separate physical node as a name node. Then you
Yeah, I
assign.
understand. That
Okay.
is, we don't call that one as a no, we don't call that one as a name node or a data node, but we call that one as a master node and a slave node. And
Okay.
the technology, it is not of nodes. The technology we talk about a name node and the data node. That is how
Okay.
it goes,
Okay.
Sarvana. Okay,
Okay. Yeah.
sure. So we have this client which is having this name node and then which is trying to store that particular data over there, and based on this name node, we have stored this information here. Now, not only that I want to store this information, I also would like to process the information. What is that one that I want to process the information? I would like to find out the total occurrences of every word in the file. Total occurrences of every word in the file. Okay. So here I have a sample file that is doing. Do you feel excited? Excited about Hadoop sessions? This is what is your file. Assuming that this is the file that you are having here. Okay. Once you think that this particular file is existing, then I have splitted this file into two components. Okay. So let me take this one. So this is the file, and then I have splitted this file into file1.txt and then file2.txt. And based on this one, I would like to execute this particular program. Okay. For the purpose of executing the program, I have written a program called as word count program I have written. Okay. Now, this client would like to submit this program to this HDFS file system for the purpose of processing. Okay, so we would like to understand the steps that are involved here. Okay, when we want to understand the steps, the first step is going to be client will approach which one? Client will approach the job tracker. Approach job tracker. Okay, so what is this job tracker here? This is the job tracker that is nothing but a process which runs in its own separate JVM. The reason why I'm telling it as a separate JVM is job tracker and the name node does not collide with each other. That's the reason they will be having their own separate spaces for the purpose of running. Okay, so client approaches this job tracker. So that's why we are expecting to have some other processes. Okay, some other process that exists, and then that process is what is called as a job tracker, right? Saran, you are following?
Yes.
This is
Yes.
what is called as a job tracker. I'm saying here.
Sure.
This is what is your job tracker. Okay, so what is this job tracker is expected to do here? Client submits this job to this job tracker, and then what it says, hey job tracker, I'd like to process this particular file. I would like to process this particular file, and the name of the program is word count. So that means that it is going to provide some parameters here. It is going to provide some parameters. So what are the parameters it is expected to provide here? What are the parameters it is expected to provide here? So the first thing is that it specifies the name of the job. The name of the job is nothing but your word count. The name of the job is nothing but the word count. And what is the second one that is going to provide? Second thing that is going to provide is that it is going to provide the file. Why? Because this is a place where your information is existing. It is going to provide this file.txt. And the third thing what it is going to provide is that I want to store the result, right? So when I want to store the result, okay, the tradition is the client also should provide the directory where your output has to be stored. The directory where that output has to be stored. So that's why it need to provide a directory that is nothing but your output directory. It need to provide. You need to provide the directory called as the output directory that you need to specify. So these are the three things that it is going to provide. So that's why it should provide the name of the file, it should provide the program name, as well as it should provide the file.txt, as well as it should provide the output directory in order to process that data. You should provide the output directory in order to process that data. Okay, 1 minute. It should provide the output directory in order to process that data. Okay, now tell me what should the job tracker should do first, guys? Please tell me what should the job tracker should do first.
Check for the file existence.
Sorry.
Check if the file is present.
Check if the file is present. So how it will do here? This see here. Job tracker is going to talk to the name node. Why? Because it need to understand the location where this file.txt is located. Where this file.txt is located. So that's why what happens is that job tracker is internally going to contact this name node. Job tracker is going to internally contact this name node. Why? Because it want to understand the location where this file is stored, right? So guys, I want to have this session as an interactive session. Please understand. Please interact with me. Why? Because this is something that is going to help you in order to understand the complete architecture, how this MapReduce is going to work. Sarvanan, okay?
Okay.
So the first thing is, the one thing that is going to happen is client is going to, job tracker is going to contact the name node. That is, job tracker is going to contact this name node. So for what purpose? For what purpose it is going to contact this name node?
The name node, it will tell basically where the blocks of the file are, to give that information.
So where the blocks of the file are, right? Yeah. Where the blocks of the file are. So right. In a sense, it want to understand the location of the file, right? It right. want to understand the location of the file. Location of the file, it want to understand. Okay. Now, what the name node should do? Here the file splits are there, right? File1.txt and then file2.txt. It has been stored in 3 locations here. It has been stored in 3 locations. How do you know that they are in 3 locations? File1.txt is in 135 and then file2.txt is there in 236. Okay, my question to you is that is the name node is going to return all these 3 blocks, or the name node is going to return only 1 block?
The name node will return, I read this actually, the name node would return all the 3 blocks sorted in the order of the network topographical distance from the client. So whichever node, data node is nearest to the client, it will return, it will sort it in that order and return it back to the name, return it back.
Yeah. So see, the name node is going to return the complete metadata information to this job tracker, okay, sorted in the order of local proximity. Local proximity, Sarvana.
Right.
Local proximity means whatever the slave node that is nearer to this name node and the job tracker, that will be specified first. That will be specified first. Okay. So the name node is going to give that information to this job tracker with respect to the places where this entire information is existing.
Correct.
Okay.
Nearer to the name node or nearer to the client, Ravi?
Nearer to the client. Nearer to the client.
Nearer to the client. See, the thing is that nearer to the client and these nodes are there in a separate geographical locations, right? So whatever the thing is, the network information has to be flown from the client to this data nodes. Okay, that is the reason which are nearer to the client in one sense, and which are nearer to the for job tracker. For job tracker, what happens is that everything is going to be same, right? For job tracker, everything is going to be same. But what is one thing that is supposed to delegate the things that are supposed to delegate the things is nothing but the job tracker. So which one is nearer to this client? That is something that has to be given as the first priority, Murli. Okay.
Yeah, got it. Client makes sense. Yeah, you said name node, so that's why I asked again. Yeah.
No. Name node is going to give these particular data nodes in a sorted order. Okay. According to the local proximity. Local proximity means local proximity to the node who is submitting the job. Who is submitting the job here? The client is submitting the job, right?
Right.
That's the reason.
Yeah. Okay.
That is one version, and second version I will tell you at a later point of time. Okay, please hold on. So it gives this one. So what it will do is that it will not consider about the other replicas what it is having. It is going to consider only the first replica in order to process this node here. Okay. Now what is going to happen here? So at each and every data node what you are having, you are going to have one more thing that is going to exist. Let me save this one here. This is main. Okay. Now see here. This is your name node. This is your name node, and within this name node you have two processes here. What are the two processes here? One is your master node here. This is your name node. Okay. And the second thing what you're having here is this is the place where your job tracker is also going to exist. Job tracker is also going to exist here. Okay. Now I have two data nodes here. Okay. I have a data node 1 as well as I have a data node 2 where my files are present here. Okay. This is generally treated as data node 1. This is generally treated as data node 1 as well as this is treated as data node 2 here. This is treated as data node 2 here. Okay. So within this data node, what you are going to have here, you are going to have something called as a task tracker that exists. Task tracker. You're going to have this task tracker as well as you're also going to have this task tracker that exists here. You're going to have this task trackers that exists here. One is the task tracker as well as the second is the task tracker that exists here. So this is the place where your file1.txt that exists, file1.txt, and this is the place where your file2.txt is existing here. File2.txt is existing like this. Okay. These are the two things that are existing here. Okay, now what the job tracker is going to do here? The job tracker is going to delegate the request is going to delegate the request to this task tracker, as well as it is also going to delegate the request to this task tracker also as well. Task tracker. So what is the task tracker? The task track. This is going to delegate the request to this one, as well as this is also going to delegate the request to this task tracker also as well. Okay. So see, just like there is a relationship between name node and data node. Okay, there is also a relationship between the job tracker and the task tracker. See, that means that when the job tracker is going to delegate the request to the task tracker for the purpose of processing the file, okay, task tracker is responsible for the purpose of submitting the status of that process to the job tracker. Okay, so that means that task tracker is something that is going to work under the instructions of this job tracker here. Okay, and just like the data node is sending the heartbeat to this name node, this task tracker is also expected to send the heartbeat for every 3 seconds to this job tracker. Heartbeat for every 3 seconds to this job tracker, making sure that I am there and I'm not dead. Okay, so that the job is getting processed here. Okay, and one more thing that you need to understand here is this task tracker. In case if it is not providing the heartbeat to the job tracker, what the job tracker is expected to do is that the job tracker is assumes that the associated task tracker is dead, and it will automatically have that second replication where the second replication is existing. It will automatically delegate the task tracker of the second data node where your second replication is existing, and then it will start the process on that particular block also as well. Till here, this information is clear to you, Divya, Divya, and Shashank, and Saravanan and Murli. Is this clear to you?
Yes, Ravi, it's clear.
So Ravi, the terminology you use for the process is the same. The word count.java file, right?
No. Java file is a program.
Okay.
Java file is a program, but this is the internal processing in this Hadoop.
Okay.
Okay, and this task tracker is expected to execute your program. What are the programs that you are handling? Right? You have a program, right? What is the program here? The program is nothing but your word count.java. Shashank, can you please go on mute? Word count.java. So when the job tracker is going to instruct this task tracker to process this file, what it is going to do is that it is going to pass this code to this data node for the purpose of processing this file here. Okay, so that means that what we can say is it is the program that is traveling from the master node to the slave nodes for the purpose of processing the data which are there in this local data node. That is one thing that you need to understand. Okay, that is one thing that we need to understand here. Saravanan, is it clear to you what I am talking here? Hello? Saravanan, is it clear?
Yes, Ravi. I was briefly logged out. Yes, it is clear to me actually. Yes.
Okay. Now, this word count.txt is coming into this data node as well as into this data node. Okay. Now, what is going to happen here? This so here you have the relationship like this. Here you are going to have the relationship like this. The relationship is nothing but it is your task tracker. It is your task tracker. Sorry. Is your task tracker. Okay, and second thing is there is also going to be your some other process in between, and you are also going to have the place where your data node is there. That is nothing but your file.txt. This is nothing but your file.txt. file1.txt. This is nothing but your file1.txt. So the relationship is like this. Task tracker is going to initiate a process in order to process the data that is present in this file.txt. Okay, what we do is that we call this particular process as mapper here. We call this process as mapper in this particular case. Mapper. We call this process as mapper here. Clear? Task tracker is going to initiate a process for the purpose of processing this file1.txt, for the purpose of processing this file.txt, and then this particular process is called as the mapper. Okay, now the question is how many mappers are required here? How many mappers are required here? Guys, can you tell me how many mappers are required here?
2.
Two mappers are required. So what is the formula that we need to use here? The number of input splits what you are having, is equal to the number of mappers that are used for the purpose of processing those file splits. The number of file splits is going to be equal to the number of mappers. Okay. Now, how are you going to decide the file splits, Divija? How are you going to decide the file splits? How are you going to decide the file splits?
Depends on the size of the file, and it's broken down to 64 or
It
128.
depends on the size of the file, as well as it depends on the block size that has been specified for this Hadoop distributed file system, right? That is
Yes.
distributed for the Hadoop distributed file system. So these are the two things that you need to understand here. Okay, now let us focus on what this mapper is expected to do. What this mapper is expected to do here. Okay, so I was telling you there is a file, and that file is hi, how are you? Welcome to data analytics. Okay, welcome to analytics. తర్వాత for your studies, who is your family. Okay, this is your file here. Who is your family? So assuming that this is your file. So I'm breaking this file into two places. This is the file 1 as well as this is the file 2. This is the file 1 as well as this is the file 2. Okay, in the file 1, what you're going to have here, you're going to have the data up to this 2 sentences, which is being splitted here. Paste this one, and you have this data which is existing here. Sorry. Paste it here. How are your studies going on? How is your family? This is what is your data that exists like this. Is it clear? Now, initially when the mapper is going to process this data, what is our total objective of the job? The total objective of the job is what is the total objective of the job? The total objective of the job is to
For the word count, right?
to find out the total occurrence of every word in the file. So what should it do here? What should it do? So when the mapper is going to process this data, Shashank, what is something that you expect initially? What is something that I expect initially when the mapper is going to process the data?
Each word according to the occurrence.
Yeah, tell me.
It should index the count of each word according to the occurrence.
It should index the count of each word. Okay, right?
Yes.
This is how, and you have this R, and then you have this O, Q, and then like this you have all these things here. Like I'm taking very few, and this is this one here. So it is going to split each and every word. It is going to split each and every word. Okay, and then it is going to say here, hi has come once. Okay, and how is coming once here? How is coming once, as well as R is also coming one. R is also coming one, as well as U is coming. U is also coming one, as well as welcome is coming also one. So you know what is this type of pair called? This type of pair is called as the key value pair. This type of pair, what we are calling here is nothing but a key value pair here in this case. This is called as a key value pair. Key is nothing but the index as what he's been telling you, and then value specifies the occurrences that are existing here. The occurrences that are existing here. Okay. Now, hi, how are you? Here, suppose if I specify one more word saying that how is life? If I specify like this also as well, okay. Now, what should happen here? I also need to specify how is coming as one along with one that is coming here. How is coming two times here, right? This is what is called as the enumerated list. Okay, this list also I need to specify here. And similarly, how are your studies going on, and then how are your family? So here also I need to emit these value pairs here. I need to emit these value pairs. How exactly I need to do here? This is going to specify something like how one R is one, your is one, like that. It is going to emit all these occurrences of every word within that particular file partition. Within that particular file partition. Okay. So this is something that the mapper is going to do. That means that the mapper is going to process each line of text. Each line of text here, and within that one, it is going to split each and every word, and it is going to understand the number of occurrences each word is having, and it is going to output this particular intermediate data sets. Okay, so these sets what you are having here are treated as intermediate data sets here. Intermediate data sets. Divya, you are following?
Yes, Ravi.
Any questions at this point of time? Intermediate data sets.
No.
These things are treated as the intermediate data sets. Murali, you're okay.
Yeah, I'm fine.
These things are treated as the intermediate data sets. Now, tell me what should be the next step that we need to do? What should be your next activity that we need to do?
Aggregate the count.
That means that whatever the things that are there, this one minute. This one, sorry. I'm going to copy, as well as I'm going to create a new slide, as well as I'm going to paste it here. Okay, now this is the result of your mapper one. This is what is your mapper one, and this is what is your mapper two here. This is what is your mapper two. Mapper two. Okay, now what I need to do here, I need to have one more process that will be able to combine this partial result set and then this partial result set, and then it will do some process in order to give you the total count of occurrences in this total file itself, right? So that's why what we are doing is we are going to call that particular process as the reducer. We are going to call that particular process as the reducer. The reducer is expected to here. The reducer is supposed to pass on this input here. The reducer is supposed to pass on this the mapper is the reducer is expected to take the output of this one and then this one, and it is going to combine all these things, and then it is expected to produce an output file. It is expected to produce an output file saying that how is repeated three times. How is repeated three times. Okay, as well as R is repeated. How many times here? Two times. Okay, like that. Welcome, what you're having here is repeated one time. This is the ultimate output that has to be given by this one. So that means that whatever the intermediate result sets that the mapper is producing, those intermediate result sets are fed as input to this reducer, where this reducer is going to combine and sort all these key value pairs, okay, before it is going to perform the final calculations on those key value pairs in order to give the ultimate result. Okay, so that ultimate result, what you are having here, 1 minute. That ultimate result, what you are having here, is expected to be in which place? Is expected to be an output directory, and it is supposed to produce that output directory also as well. I'll show you how exactly that output directory is going to exist. Browse the file system. This is user. This is Edreka. This is your out1. Within this out1, you have this data like this. When you open this output data, you are going to have here. This has occurred 2, A has occurred 2, demo is 1, Hadoop is 1, map reduce programming 1. This is this one here. This is what is the output. But what is the input that you are having here? The input what you are having here is see here. This is a Hadoop demo. This is a Hadoop demo. This shows how to reduce a map reduce program. Is it not something like this is coming 2, is showing 1, A Hadoop demo, and everything else is showing 1 occurrence in this pair of text. Okay, guys, is it clear what I'm talking about here? Sarvanan or any other people or any other questions you are having here, please let me know. Now I have a couple of questions to you before we go ahead.
Okay. One question I had, Ravi, how is the yarn different from the map reducer? How is their architecture different?
See, anyway, we are going to discuss that architecture maybe in the next week. But
Okay.
let me tell you a very high level difference here.
Okay.
You know, in a cluster, you are going to have some thousands of nodes, right? In a
Right.
cluster, you are going to have some thousands of nodes. Okay. And they are nothing but the data nodes only. And every data node is going to have the task tracker, right? Every
Correct.
data node is going to have the task tracker. So for every task tracker, there might be some hundreds of mappers that might be working, as well as there might be some hundreds of reducers that will be working also as well, right?
Right.
For every task tracker, what you are seeing here, there might be hundreds of mappers that might be working, as well as hundreds of reducers that will be working. Okay, and what is the purpose of the job tracker? The purpose of the job tracker is to keep track of each and every task tracker that is existing, right? To keep
Correct.
track of each and every task tracker that is existing. So that means that don't you think that this job tracker is totally busy in resource allocation along with the scheduling of those task trackers, along with the monitoring of those job trackers also as well, which is not
Right.
which obviously is a tedious task, especially when you're running a cluster with thousands of nodes, right?
Correct.
So in order to relax the performance of this job tracker, that is a place where your yarn has come into the picture. Yarn has
Okay.
come into the picture.
Okay.
So that's why that in the case of the map reduce, you're going to have, in the case of the map reduce, you are going to have only the name node and the data node and the secondary name node, job tracker and the task tracker. Okay, but when you go on to the yarn, you are going to have the resource manager, application master, like that. The technology is going to be different. Okay, so before you want to really get into the internals of yarn, we need to have a complete clear-cut understanding of this map reduce server run before we go ahead and then start looking into that one. Okay.
Mm-hmm.
Clear what I'm talking
Right.
here?
Yes.
Yeah. So any
Ravi,
other questions? Yeah, tell me.
this particular example, like name node returned 1 and 2, right, for the file splits, file 1.txt, file 2.txt.
Mm-hmm.
But data node 3 has both the splits. So it can return 3 as well, right? Like it is because both splits are there. How does it apart from local proximity? Is there any other thing that it will consider?
There is something that will get into the Hadoop administration at that point of time, but from the developer perspective, whatever the nodes that are there in the local proximity, only those nodes are expected to be considered. Okay, and another thing, we expect blocks. See, one rule that they follow is that we expect those blocks to be in separate data nodes for the purpose of processing. Just in the interest of not eating up the resources, Murli. Just in the interest of not eating up multiple resources, we expect those nodes to be distributedly processed.
Okay. Yeah.
You got my point.
Yeah.
That's what it is going to do. So, Shashank, is it clear to you what you're talking here?
No, Ravi, could you just repeat that, the last point you made?
See, what Murli is asking is, you have this file1.txt as well as file2.txt in node number 3 here. Okay, in node number 3 it is there. So why can't this job tracker, okay, instead of giving node 1 and node 2, why can't it give this node 3 directly, assuming that 1 and 2 are present here? 1 and 2 are present here. Okay, you got the question, Shashank? What he's asking?
Yes, Ravi.
So let me tell you the explanation on that one. Two options. One option is blocks are totally different. Blocks are independent. So it is of no matter on what data node these blocks are present. Why? Because these blocks are ultimately being executed by those mappers in its own namespace. So that's why from the outset it does not really mean whether both are existing in the same data node or both are existing in the different data node. It doesn't mean that much. Okay, but when you take it the second outset, what happens is assuming that this task tracker is dead here on this name node Murli. Okay, this task tracker is dead. Then what will you do, Murli?
And it initiates another task tracker on a different node data.
Two different task trackers on two different nodes it need to initiate, right? Two different task trackers on two different nodes need to initiate. Murli, you are listening?
Yeah, I'm listening. Yeah.
So, which is a cumbersome process, right?
Yeah,
if
right. Yeah.
Both are existing. If both are existing and working in two different nodes, then it is okay. Okay. So that is the reason we expect the blocks to be existing on different nodes, and the same way the job tracker is expected to assign those mappers or the task trackers to the nodes which are to the blocks which are in different nodes only. Okay.
Yeah. Okay.
Okay. Now tell me, how many mappers? Who is going to decide the number of mappers, and who is going to decide the number of reducers here?
Job tracker.
Job tracker is going to decide the number of what?
Mappers.
Job tracker is going to decide the number of mappers. Okay. And who is going to decide the number of reducers?
I think that's going to be same. Like job tracker will decide on both.
See, depending on in how many number of files you want to write the output, that many number of reducers has to exist. See, suppose I'm interested to write that data only in a single output file. my logic. Okay, then in such a case, one reducer is sufficient, right, Divya?
Yeah.
Okay, but there might be some logic, assuming that you have an employee file. I would like to bifurcate the employee data into two separate files, whose salary is less than 50K and whose salary is greater than 50K. Then I need to put the data into two output files. Then how many? Uh, files are required? Two output files are required. So two
Two
output files is
reducers.
going to be two reducers. So who is going to decide? It's not the job tracker that is going to decide. It is not the mappers that is not going to decide. It is the client or the end user who is going to decide the number of reducers that has to be used here. Okay.
Okay.
Sarvana, is it clear? And
Yes,
Shashank.
yes, Ravi.
Now, another thing. Do you think that a program will always have both mapper and reducer, or else it will have only mapper and then no reducers? Can there be a situation where you have only the mappers that exist with no reducers?
Yes, there can be.
Why? Because I just only want to process the data, but I don't want to store any output results. In such a case, what happens is that there might be a situation where no reducers also exist also as well. Okay, this is one thing that you need to really understand. Okay. Okay, so what are all the minimum components that are required for the purpose of executing this MapReduce jobs? Can anybody tell me? Minimum number of components that are required to execute this MapReduce program. What are the things that are required based on the discussion that we had? Shashank or Murli, can you tell me?
So I think uh, the name node, the job tracker, and the task tracker,
That
and
is
the
internal
dashboard.
that we are talking. I'm talking about the components. We have to have a program, right? We have to have a Java program. We have to have a Java program. We have to have an input file. Okay. We have to have the